Okay, let's get started. And there was a question. No? Yeah. So yeah, the concrete listeners they'll either send a text message or send an email or print out to the console. Yeah. Any other questions? So last time, when these things have little batteries in them, and surprisingly last as long as they do, but I didn't recharge it soon enough, and so if you listen to the last lecture online, it goes until all of a sudden then drop. So I actually bought a new pair. So the battery should last a little longer. And the problem is that they'll tell me when they're out, but when they're out, it drops the connection, and then what's that? Yeah, yeah, it gives you a little beep. Your battery's dead, but it's too late. Then the connection is dropped, and then the system that's recording then. So we're talking about the observer pattern, reactive-x, and we're going to talk about some other patterns. And at first, it won't make sense why we're talking about these patterns right now, but either by the end of today or next week, it'll become clear. So I want and to motivate the template method, I want to talk about polymorphism, right? And so here, one of my few C++ examples, I have a parent class account, and then I've got a junior account and a savings account, right? And then when I create a customer, and I have some method called create an account, and it returns. We don't know which one it returns, right? It could be a parent one, a junior, or savings. And then when we call a transaction on it, then the question is, which method is called, right? And we all know that it depends upon, what class was created, right? If it was a savings account, then it's going to call the one a savings account. If it's the junior account, it'll call that transaction, right? Although for those of you who don't know C++, it's a bit more complicated in C++. So there's several key factors you need to have. The parent one has to be virtual. If it's not virtual, then there's no polymorphism. And you have to have a pointer to the object. If it's just the object itself, it doesn't work. But that's just polymorphism, right? Basically in Java or Python or Swift, when you send a message to a class, it doesn't declare what the declare type is. It matters what the actual object is. Oh yeah, and so in C++, we can basically have abstract methods by assigned to zeros, like what? So template method. So here, right, what we do is a transaction method is a class has a bunch of other methods, transaction part A, B, and C, right? And then this transaction method will call those methods, and there may be other code in there, but it calls them, right? And then what we can do is, then the subclasses, instead of overriding, right, the full transaction part method, it can just implement one of the parts. Right, so maybe the junior account implements part A, and the saving account implements part C. And now when we call the transaction, we are calling the transaction in the parent class. But what's happening is when the parent method, right, calls part A, if it's a junior account, we're going to call what's implemented in the junior account, right? So what this allows us to do is in your parent class, you can define a method and you can define the basic way it works, right? By calling other methods. And then your subclasses can modify what those things do by not overriding the whole thing, but by overriding just those parts. And so the method, the main method in the parent class becomes like a template, right, for how things should work, and the subclasses can modify parts of that template. That's it, right? That's a template method pattern. It's definitely easier to understand than, say, a visitor pattern. Right, and so the intent is, we define some sort of algorithm, some method, and we then allow the subclasses to modify parts of it by implementing some of those other methods. And this is the most commonly used pattern from the book. Almost every library you use or framework you use uses a template method. So here's an example. Before Java had FX, it had swing, and when you wrote a swing application to GUI, what you do, you would subclass frame, and then you would implement a method called paint. And in the paint is where you'd actually do whatever you want to do on the screen. But what happens is, the frame has this algorithm that says, okay, it has to look for events from the user, and then draws a screen. It's got this event loop it's doing, and part of that event loop is continuing updating the screen, right? And in that algorithm, there's a method it calls called paint, right? Right? And so this is an example of template method, even though you can't see it, right? And it also illustrates one of the issues that happens with template method is that is what they call inversion of control, right? Because your class is no longer in control, right? You don't call paint, it gets called by, the parent class. Right? So beginners, when they start doing this, they don't like it because, where's my main? Where do I start? Where's the whole thing? And no, it's just another example. this is in Ruby. So I define a class LinkedList, and we define index, we define size, we define each, and we define push. And that's all we need to define. And then I can create my new linked list, and I can do push, push, push. Okay, I didn't show you it there, but then I can call select on it. How's that? Well, select is defined in enumerable, right? And it's defined in terms of, it's a template method, so we can actually, it's using these, well, we need size because you need to help iterate over. May use each or may use the index. And so it's select is implemented in terms of other methods to do most of the work. And then when we implement our own list-like structure, all we have to do is implement those template parts, right? Not the whole thing. And so here is all the methods that define enumerable, and they are defined in terms of each. And so once you've got each, you get all those, right? So it's an example of using a template method in a different way. The same thing with Java Abstract Collection, right? You implement those three methods and you get all these. Why? Because you find all these in terms of those other ones, right? Another example is for the template method. So here what we're doing is we're defining all the operations that we want in a collection based upon a small core, right? So all these things we can consider to be implemented as template methods, right, in Abstract Collection, and these three are the pieces we have to implement that are part of those. I mean, it's used everywhere, right? In version control, right? We don't mean where's it start, where's it end? No, we're starting there, and the parent algorithm, when it needs to call our code, right? So one problem is we need to know when I'm subclassing, what methods must we override? What methods can we override, right? If you don't document that, then how's the programmer going to know, right? Yeah, so template methods, they may call a concrete operation, which you can override in some class. Factory methods, we'll talk about in a minute. Hook operations where we may not need them, but we can add them, right? The parent may implement them as blank, do nothing, and then we can. And we also have to be worried about, you don't want to override the template method itself, right? The whole point is to provide this framework or how this thing works, and then you modify the pieces, not the whole thing. Again, this idea of you may not realize you need the patterns in advance, so we need some way of, once we have a system running, right? We want to modify it to introduce patterns. How do we do that, right? And so refactoring the template method. How do we take code which doesn't use the template method and add it? Is an interface an example of template method? In Java, no. Why? Because interfaces don't implement anything. But the whole idea of the template method is the template method itself does something, right? It says, here is the steps we're going to take to perform this operation. And then you can override some of those steps. Interface just says, you need these then methods. It doesn't tell us how they operate, doesn't tell us this one should call it this one. There's a default, yes. And you don't override that method. No. No, the template method you don't modify by overriding it. Correct. No. So first question is, what's a template method here? The template method is transaction. And the transaction is, oh, first you do part A, and then you do part B, and you do part C, and then there's some other stuff you do, right? We don't want our subclasses to override transaction. Right? We want to find, here are the steps we take to do a transaction. And then the subclasses are going to override, part A and part B or part C or all or one or none. And it said, there could be more in between these subparts. You could be doing other stuff, right? And so the template method may be doing a bunch of stuff, but at various points, it's going to call other methods to do various work, and those other methods are what we have the subclasses override, not the entire template method itself. So yeah, interface, not the same thing, right? So yeah, how do you refactor to template method? Well, it usually means you got a big function or method, right? And so you want to figure out, what parts of it do you want to separate into separate methods, right? Right, and they say, well, what you do is look at those and say, break them into blocks and come with those blocks. Those blocks you're creating usually tell you, oh, this might be a good, right, method. And then each one of those steps, you break it into a separate function, and then you call it and do one at a time, right, until you implement each one. And again, the idea behind this refactoring is you don't want to make these big steps, right? Because you could fall down, right? Or in the code sense, you spend the next 3 hours trying to make things work, right? You want to take little steps, like, oh, that's easy, right? I can do that. I mean, no, I'm not going to fall down. I'm not going to break a leg, right? And so I'm sure you've all done this, right? You got this code running on instant changes, and you start going and start hacking away, and all of a sudden it's like it doesn't work. I don't know why it doesn't work, and then you spend hours just trying to go back to where you were or get something working, right? So you really want to, just do this, right? Oh, it's working. I'm fine. I'm still fine, right? And so you don't take this big method and then just, no, we break it. Oh, here's my blocks. I'll take this one block. Now I can move that to and make sure it still works. Okay, and then I do the next block, right? Because it may be in this block you forgot that there's this variable here that you didn't pass in, and you move it doesn't work, right? Yeah, so functional programming. If you don't have classes, then how do you do something like this, right? Well, one way is you just pass in those pieces, right? And then when you call it, you can pass them in and it gets a little awkward because then you have to pass in all the pieces, right? And so you need to know what the pieces are, right? So it's like, doesn't sound very good. So this idea of both partial evaluation, recurring. So in partial evaluation, what I can do is I can pass in not all the parameters, I can pass in some of them. And what I get back is a function that only requires the parameters I didn't pass in. And so now I can create a default one and create another one where I change, one of the parts, and they become a separate function I can now call, right? So we don't have to remember all of the pieces what they are. I just, okay, I'm going to create using partial evaluation 3 or 4 other functions, which helps, but then we need to know what type it is, right? We need to know what type it is. Then in Lisp, they got this thing called multi-method, which basically means we can give it the same name and then just basically have 2 sets of parameters, one for the arguments and one for the type we want. And then it calls the right function for that type. So I can still use the same name, transaction, right? And then I can call those other methods we generated. And so from the outside world, we just call transaction and say, oh, here's the account, right? And it dispatches on that count type. So we can do this in Lisp, we can do it in Julia. I assume Haskell and Camel do the same thing, but And the idea, as we said several times before, is when we start getting languages that are simply different than Java, right? Some of these patterns will be handled differently. And you really wouldn't call it a template method in this case. You know, so comparing them, right? The variation, right, goes across different files. Here we can do it in one place. To add new variation, we need a subclass, right? We just add a function. The logic is in the parent, you know, in a class and parent class, and then in functional, it's just in the functions, right? So that's template method. And the reason I want to talk about template method is I really want to talk about factory method and abstract factory. And abstract factory is even simpler to talk about. It's a template method for creating an object. So bar is a factory method. What does bar do? It creates a new object and returns it. That's it. That's the factory method. Right, we're done. You now know what the factory method does, how it works. Yeah, that's the question now, is why bother, right? So there's several reasons. One is the same thing with the template method. Subclasses can override your factory method and return something different, right? Another reason is you may need that create bar objects in multiple places in the class, and so having the factory method allows you to do it in one place and call it, in case you ever want to change your mind and have it create something different. The example they give is, you know, I build this maze game, right? You've got rooms and walls and doors, but some have bombs in them and have these other weird things going on. And so using, right, the factory method, we can now the parent class can have a bunch of factory methods, right? Create a door, create a wall, right? And then maybe there's a method to create mazes, right? And so I create a bunch of stuff and return it. But then I can subclass it, and now I can create a different type of room just by overriding that factory method. So the main reason for doing the factory method is the subclasses can create a different type and return that. Now in the Java world, the other type of returns has to be a subclass of the type the parent returns, right? Because you basically specify this method returns this type of thing, and so the subclass has to return the same type or subtype. Python, who cares, right? Return whatever you want. You know, another reason is, okay, we can just I didn't get the first part. A constructor? But constructors are not methods. The rules for them are different, right? You can't, your subclass can't override the parent constructor. And the subclass constructor, well, yeah. And then the book talks about various different ways we do it. Give it a parameter to determine what type we need to do. In C++, we use templates to do weird things.
Hershey.
You don't understand. But this is not generic. Right? It's just a factory method with an argument which helps you select which thing you want to return. I've never seen anyone do this, but and then we can do crazy things with C++ templates. But and Smalltalk has this weird thing you can do. You can actually pass around names of classes. And in Smalltalk, because there's no difference between a constructor and a method. So it's not, a constructor isn't something special that the compiler knows about. It's just another method you call in the class. And so I can just pass back the name of a class, and then I can call it and call a method on it, which their constructors are called new. So I don't have to do new this to return, I can just return the class, and then that's good enough. So they talk about when you want to use the factory method. And so the last one is easy, right? There's 5 spots in this class. I'm going to create an object of this type. And so instead of embedding everywhere, I can create a factory method, right? And just call it whenever I need it, right? Class wants a subclass of specified objects when it creates. That's a little bit harder to understand, right? When that might want to happen. We'll see an example in a minute. And this is probably even more mysterious, right? When the class doesn't know what it wants to produce, right? But at least you can understand, okay, that allows me to change one spot, what gets created, and then I have to go through to everything. So one example where I use this is when I used to teach 580 client-server programming. You have to build a server, right? And the server basically listens to a socket and for an incoming message, and it does a bunch of stuff, and then returns the answer. And so then, how do you actually know that your server works? Well, one way is to write a client to talk to your server, and then start your server up and start your client up and then see how, sort of bad idea, because now when it doesn't work, is it the problem of the client or the server, right? You have no idea. And since the server is big and the client is big, you got lots of code and you have no idea where the problem is, and it's a nightmare, right? So how can we deal with this? Because at some point, right, we have this loop that's going to do a bunch of stuff, right? And the loop is going to listen on a socket and then wait for something to show up, right? So how can we test that loop, right? And see where I pass this in and then I get this back out. So one way is we use the factory method, right, to create our server socket, right? That allows us to create a subclass, right, that can override the socket. And what we want to do conceptually is create in some sense, a subclass of server socket that when you do accept on it, returns a fixed answer, right? And then when you write to it, it records what you wrote, right? So then what we can do is, write a subclass that only differs in the parent class by what socket type it produces, right? And we want that socket to be able to have fixed answers when you listen to it, and then you want to record it, the responses that you write to it. And so then you can, do a bunch of stuff, and we don't need a network to get our servers, right? And the only difference between our subclass and the parent class is that type of socket, right? And so all of a sudden, what seemed like an impossible test, but you needed that network, right? And of course, we always test pieces that don't have access, don't need access to the network. But here, I can actually, test the whole thing. And then what happens is, once you write the subclass, the server socket thing, to have fixed responses, and then record what you write to it, you go, this is a lot of repetitive work, right? So people created what they call the mock classes, where you can literally say, oh, give this class the same interface as that class, and for method X, here's what you return. And method Y, you record everything that is sent to it, right? So this is one example where I can create a subclass that wants to create something different. And since that's the only thing that's different between the two classes, right, if it works, and then I'm a bit more confident that my server works. And so then when I start building a client, I can talk to it. And if something goes wrong, it's more likely the client, right? Make sense? Now are you starting to see why I want to talk about factory method? Right, yeah. Yeah, and so this mock server wrote it. There are other ways of doing this. And there's a fancy term. It's like, I don't know how people get away with having this fancy term for something so simple, right? It's like, really? I mean, you want to use that? You want to call this dependency injection? What does that concretely mean? Well, there's several types of dependency injection, and one is I just pass in something in the constructor. Like, that needs a name, but it has it. It's called dependency injection, right? So one way to do the same thing is your server has a constructor and you pass in the socket type you want to use, and then you can either pass in the real socket or the mock socket, right? And that's called constructor dependency injection. And then there's setter dependency injection, where when you have a set method, right, and you call it and you pass it in. And then people have talk about why is constructor better than setter, and sometimes you need setters because there's too many arguments you may want to pass in. And it's like, yeah, it's just the constructor and a setter, right? And yeah, it's like there's constructor injection, setter injection, and then it gets interface injection gets more complicated because what you do is you create an interface that your class implements, and then that interface tells the world what you can inject into your class, and then people create injectors that will then do the injection for you. And then what you do is you have a configuration file that says, okay, when I run this program, read this file, and it'll tell you in this class the type of thing I want to inject in there so you don't have to do it in your code, right? What's that? No, the clients use the injectors to get the objects. And yeah, yes. In Spring, you have injectors, right? Yep, and that's it. And injectors are just dependency injection into your classes. And so that's template method, factory method. It's like break from patterns. There's a book out called Effective Java, and it's in second edition. I think there's a second version of it. But it has all the ideas of how to be better Java programmers. And so yeah, it came out a long time ago. Yeah. And so, he has a bunch of these little things. And the first one was use factory method. And so yeah, make static factory methods because you give them different names, right? With constructors, they all have the same name, right? And what happens when you want to have two constructors in your class with this, say, one argument, both ints, you can't do it, right? Because that int has to be remembered the same thing in a constructor, whereas the factory method, you give it a different name, and yeah, then, right? And so, yeah, I mean, the string class is value of, and you just example of a static factory method. And then there's, there's the same, you have names, right? you don't need to create a new object each time. You can return an object of any type, right? Another example of using this, in Java, when you need to box, if you want to put an int into a array list, you can't, right? Because you want to put objects, and int is an object. And so you have to box them, right? And so you can box them by, Java now has auto boxing where it does it for you, but they still have to say, oh, it's an integer, so I do new int, right? Or it's a float, so it's a Boolean. And so Objective-C, that's just crazy. Why do we have to say new int when you box it? Just create. There is a number class, and there are static factory methods to box them for you, and you just say, give it the value. An integer or float or Boolean, they're separate factory methods, but they have the same name, right? And they wrap them for you. And the nice thing is then, as an Objective-C programmer, they never knew that there was a integer object and a float object and a Boolean object. It was just a number. Right? And the number was a parent class, and so all the subclasses are the same methods, and so putting things in or out was the same. So it simplified things. And they had a thing called class clusters that go, so you're basically hiding all those all those subclasses from the world because you don't need to know them. It's something that the compiler need to know about to make things work, but made life easier. Except when you want to explain to students what was going on, like, no, it's just number. No, it's not just number. I mean, look at the subclasses, but you can't see them because they actually hid them. When you look at the documentation, you wouldn't see it. They didn't want you to see it. Yeah, and there are no constructors in Smalltalk. And why do we have a special construct to do that? So what you think is a constructor in Smalltalk is just a static factory method. That's it. Item 12 was minimize, accessibility. Back in 2001, he's foreseen, right, important aspect of functional programming, making it as immutable as possible. It's simple, thread safe. You don't have to worry about them changing. You can pass them around. You can share them everywhere, right? No problem. And they make good building blocks, right? They don't change under you. Oh yes. So don't give methods that modify those things. Make them final, so you can't subclass it and modify yourself. Item 24 is make copies. So here, some class, and you pass in 2 dates, and then you just assign them to this, right? What's the problem with that? What's that? Right. So you're giving, right, the outside world access to your internal representation, because if you pass it in, they have a reference to it, they can change it and it changes yours. And on the flip side, if you return it, they have the same copy you do, right? They modify theirs, right? Yours changes. You modify yours, theirs changes. So So don't do that, right? Don't do that. So, when you pass in an object, make a copy, right? Because now it's your copy and no one else can change it. When you return it again, you may want to make a copy so that again, they can do whatever they want with theirs and yours is not affected. Ah, well, you know where that came from, right? Yeah, so he talks about using preferred interfaces to abstract classes. Most languages now come with large libraries. Java is huge, right? But it's good to know it's there because there's nothing like spending a week implementing something and finding out, oh, it was right there. So here you might want to use some sort of compound key with a name on a pound and some unique identifier. Oh, rats, right? So when I create a compound key class, right, then they give you the name and then again, we program to an interface, right? Right, so the first one is more flexible because maybe I don't want to use an array list. Maybe I want to use an array list as a vector. I can do that the first one. Second one, I can't without changing its type, and then I have to go look at all places used and change all those places. Yeah, if there's no interface, but now for another pattern, we get plenty of time for this pattern. So their motivation for this pattern. So we want to create a cross-platform system, right? It runs on different, and so yeah, we need a menu, but there's how you implement menus on Mac OS or Android or Windows or Linux are different, right? And so basically every sort of widget you've got, right, there's going to be a different concrete implementation that we want to create. And so we'll create an abstract class or some sort of interface that explains, here's the methods that we're going to allow on menus, right? And as soon as we're in our code, we say, a new Mac menu, we're dead. Because now if we want to port this application to Windows, we have to trace down every place you specified Mac and place with Windows. And then when you port it to Linux, you have to trace them all down again, right? Not gonna, just a nightmare, right? So we can create an abstract factory. What is it? It's basically a class. All it does is create things, right? So, we'll create maybe a parent one to explain all the things we can create, and then we'll subclass it for the Mac OS and for Windows and Linux and Android, and right. And then whenever we need a widget, you go to your abstract factory and say, give me a menu, give me, right? And your code, then you basically only want one place where you instantiate the concrete type. And maybe you have an injector or some sort of thing. We put it in a file, and then it creates the right one for the platform you're on. And how to implement our factories? Well, one way is that each one of these methods in our factory is a factory method, right? And so when you have multiple things that you want factory methods for, and there are classes of them, right? And then we can use an abstract factory and use that to get all the things we need, right? So we never mix them up. Is this like a singleton? No, the singleton ensures there's only one instance, and gives you a global access to it, right? Now we use a singleton to hold our abstract factory, but that's not necessarily required. You can, but usually you just want one, right? But that doesn't mean you need global access to it. If you want, yeah. Now, right, once you've got your factory, now we can create menus, whatever, and then you don't know, you don't have code dependencies saying, oh, specific type.
Like how was it before? Because obviously they only changed.
Yeah, right. It's concrete, right? And so now this code is not cross-platform. Where here, when I pass in my factory and I say, again, the more of an example they give, right, is building a cross-platform system, but that's not the only place where we may need one abstract factory. Right, and like once you understand how the abstract factory works, then its intent is easy to understand. But if you do the reverse, it's like, well, when's that? How they create things, so subclasses can have, right, just implement factory methods. It's pretty straightforward, easy to understand. We can basically use a template method, right? What for the factory, right? I mean, they're just yeah, and using the factory methods, there might be more than one way to create a particular type of widget, right? So that using the template method, right, makes it a little easier to do more. We haven't talked about the prototype pattern, but we can create instances of each one, and the subclasses then instantiate their types, and then you just clone it, right, each time you want one. And so now the fun part is there's nothing preventing us when I pass in our abstract factory and I say, give me a menu, then downcasting it, right? And then we now have got a concrete dependency where we don't want it. And later we'll see a pattern that allows us to make sure this can't happen. Questions? It gives you one way of doing it, right? I haven't looked at the Java factory method, so I have not looked at the Java factory methods. What's that? Well, the patterns are there to be used as appropriate. Do you have a case where you would have when you come up with a case where you want an abstract factory with non-factory methods, let me know. So that was, what, 3 patterns in one lecture, plus some extra material, and we're like 10 minutes left, right? All right, I can't. One monitor turned itself off. So we'll go for a record, 4 patterns in one lecture. The null object. This one should be easy, right? What does the null object do? Nothing, right? There it is, right? You have some sort of interface for abstract class, right? And the real one, and then the null object subclass, and what does it do for all those methods? Well, it does nothing, right? So the question is why, right? Why? Let me give you an example, right? And so I want to create a linked list, and I want to, in this case, I'm going to do a bunch of stuff on it, but I'll just print it out, right? And what I want to do is I want to print out fancy, so parentheses, and then item, and parentheses, right? And so what I have to do is, well, I have a linked list, and then, if the head is nil, then I print out in parentheses. If otherwise, I then, do and then I start going through, and I'm continually checking, is it null or not, right? If it's null, then I'm at the end, right? And so it's not too bad, but I've got several special cases that I have to worry about. So we can use a null object by doing what? Well, for each linked list, I'm going to put a special null object in the beginning and the end, right? And then my linked list, to print it out, it says, ask the head, give me your string. That's it. Now, what does the head do? Well, the head is just a null object, and so in this case, it'll just print out parenthesis, and then whatever comes after it, right? And then a regular node, it just, you may want a space, and then you print out the element, and then what comes after you. And there's no null checks, right? Because I know there's always doing something at the end. And what does the tail do? It prints out the end parenthesis. Right? So using a null object, now I've got, instead of one method, I've got I've got 4 methods, right? But each method is 1 line long. So when we want to use a null object is when you get a lot of null checks. So if it's null, then I do this, otherwise I do that. If it's null, I'll do this or that, right? And so we can use a null object pattern and say, no, forget about nulls, right? If it's instead of the object actually being null, I'll make sure there's a null object there, and I do the same thing whether it's null or not. I call a method on it, and the null object does the right thing. The right thing may be doing absolutely nothing, or in this case, right? And so it simplifies the code, right? So 4 patterns, right? And so when they use it, there are times when you should do nothing. You want to know the difference between when you do nothing and not. We don't have to do those explicit null checks. And yeah, those null objects can be used elsewhere, right? So you may have, when the nulls are isolated. So the example I gave you probably won't need it because it's all in the linked list class. All encapsulated. Right. So what's the advantage? Well, we use it for classes, so it simplifies the client code. The new nothing behavior is in one spot. Reusable, disadvantage. Yeah, we have to encapsulate that information. Right, so we're reporting that linked list class. I mean, how it worked is you have to understand what the head and the tail do to understand the whole thing, right? And yeah, you start adding more classes, right? And yeah, you have to do that in the same way. Yeah. Well, this last one, everyone try. Whenever I give an assignment using a null object pattern, half the class wants to do this. It's like, how do I, when I add something to that linked list, right, I get to the end, and what do I do? Oh, I know what I'll do. I'll try and transform that null object into a real object and add a real null object at the end. Like, and then they get this quirky logic of the null object is sometimes a null object, sometimes a real object. And they're like, no, the whole point is it's either real or not real, right? Yeah, so we can use refactoring again. What do we do? Well, we do something like this. We want to place a new object. So we want to go to that place, right? So yeah, so we can, customer, we can add it, the null object. No, optionals are a special case, right? Because optional, they don't do anything, but that's just, and again, the linked list class, the null object actually did something, right?
Give the default value.
But the client has to do that, right? So then why not check for nil, right? That's jar doing. Right? So we create a subclass for null and add is null check. And then, what we get is start changing, if it's null, then we do this, otherwise we do that. Replace it with is null, right? And okay, well, we do this is now we can, what operation should our null do? In this case, I'll get a plan. And so we've turned a basic plan, and now we can take this and move it into that. Again, just examples of, trying to do small little steps, right, to go from where you are to where you want to be. A 30-second pattern. Ta-da! So the generalization, right, of a null object pattern, well, you have a customer, what happens when, the records are wrong and the customer's missing, you have no, right? It's just not there. Well, instead of having a special check, we can create a null object for the missing, right? And maybe the transaction was anonymous, they paid cash and like, okay, we don't know. And so now we can create another special null object, right, for unknown customer. So we don't have these special checks, right? Don't know who they were. Something happened in the records and that was lost. Get rid of these, right? So we can start creating subclasses to represent very specific cases to get rid of all these weirdo checks. Sort of a more general null object. And you'd be glad to know I went the whole hour and 15 minutes. There was no beep saying they ran out of battery life.